Good evening, everyone. On behalf of my group, I would like to warmly welcome all of you to our presentation. Today, our team is going to present on an interesting topic real time operating system, which is also known as RTOS. We will deep dive into RTOS concepts, use cases, and their importance in modern technology. Firstly, let me introduce my team member, Safal Regmi, myself, Jastika Shrestha, Rohan Shrestha, Rajak Shrinkhawal, and Suyas Kimire. We all have worked together and keep equal effort to bring this insightful overview. Before diving into the topic, I would like to ask if any of you have ever wondered how medical machines, self driving cars, or flight system respond so quickly without any error? The answer is RTOS. So, now let's us explore this topic in more detail. A real-time operating system is the specialized OS designed for the applications where time is critical. We can also say that it is the heartbeat of time-critical application. It ensures that the task meet specific deadlines, which is crucial for the systems like flight control or medical equipment where delays can be catastrophic. There are three characteristics that defines real-time operating system. That is deterministic behavior, task prioritization, low latency. These properties makes RTOS the backbone of the system where failure is not an option. Now, let us move to the type of RTOS. RTOs are classified into different types based on how strictly they handle the deadline. The first one is here hard real time operating system. In hard real time operating system, missing even a single deadline is unacceptable as it could lead to the system failure. For example, let us think of the braking system of the car. If the system doesn't respond on time, it could even lead to the loss of life or cause serious damage. This system is engineered with absolute time constraint and any delay is treated as failure. Here, the next one is soft real-time operating system. In this system, deadlines are important, but the system can tolerate some degree of delays without serious consequences. A good example would be video streaming applications or gaming consoles. A slight delay might cause a frame drop or lag, but it won't break the entire system. And the last one is here frame real time operating system. This falls between hard and soft real time operating system. Missing a deadline doesn't cause a system failure, but it can reduce the quality of result. Let us think of the weather forecasting system or data acquisition in scientific experiment. Timely processing is needed for useful output, but occasional missing are acceptable, but it may degrade the quality of our result. Now, I would like to call my friend Suyas Khimire to continue the slide. Thank you.
Thank you, Jastika. Hello, everyone. My name is Suresh Gimre, and today I'll be explaining the key features of real-time operating system in a simple and easy way to understand. RTOS is the brain behind system where timing is everything, like in medical devices, self-driving cars, or industrial robots. Unlike regular operating systems, like Mac or Windows OS, and RTOS guarantees that the critical tasks that should happen on time always happen on time without delays. Here's what makes RTOS so special. It prioritizes urgent tasks, it reacts instantly to emergencies, and it manages resources so efficiently without crashing or freezing. Now I'll be explaining the key features of RTOS. Deterministic behavior. It means that the system performs tasks in a predictable and tired manner every time. It matters because it ensures real-time system like in medical devices or car brakes respond exactly when needed. RTOS key features are preemptive multitasking. The OS can interrupt low priority tasks to handle urgent ones. Priority based scheduling. Tasks are ranked by importance. The highest priority runs first. Minimal interrupt latency. The system reacts to the external events like sensors almost instantly. Task synchronization and communication. Tasks can share data smoothly without conflicts. Memory management prevents memory leak or fragmentation, which would crash the system. Now I'll be telling you about the differences of differences between the RTOS and general OS such like Windows, Mac, or etc. RTOS response time are fixed and predictable, whereas the general OS can lag. Memory usage is minimal in RTOS and very high in general OS. Applications are embedded systems such as cars or medical in RTOS, but in general OS, PCs, phone servers counts as examples. The hardware used in feature OS are low power microcontrollers, and general OS can support high performance processors. Now I'll be calling my friend Ruan Sister for the following slides.
Uh, Thank you, Swiss Gimire, for writing over me the slide. Now I would like to present the slides further. The topic is RTOS architecture and its components. Uh, think of an RTOS like a well-run kitchen. Imagine a busy restaurant. The application software is like waiters are taking orders. These orders then go into the kitchen where the real cooking happens. This is where our kernel space is. In the kernel, we have input output management. Like kitchen, start fetching ingredients and tools. Task synchronization, making sure two chefs don't try to use same oven at the same time. Memory management, deciding how much space is allocated to each dish being prepared. Task scheduling, this is the head chef assigning which order gets priority first. The scheduler ensures the urgent order, say someone with an allergy gets cooked first. Tax management handles all the tax life cycles, that is creating, pausing, or ending a tax. Interrupt handling. Interrupt handling is like the fire alarm, it grabs everyone's attention immediately. Time management ensures each task knows exactly how much time it has to complete. In RTOS, being fast isn't enough. Being predictable is the goal. Now, moving on to the next slide, we have core components and memory management. Core components, scheduler. Scheduler decides which task runs next. It uses smart techniques like rate monotonic scheduling or earliest deadline first. RTOS schedulers are like prioritized to-do lists for the CPU. In most urgent tasks, jumps to the front. In task management, keeps tracks of what's happening, what's sleeping, and what is next. And then we have inter-task communication (ITC). Imagine if a tasks are co-workers, they need to talk. RTOS give them tools like message queues, semaphores, and mutexes to talk without shouting over each other. Interrupt handling, super fast response to hardware events. Think of it as a doorbell that can interrupt a conversation. It must be answered now, but not later. And then we have memory management. RTOS uses static memory allocation, which means everything is pre-planned, no surprises or no delays. It favors to avoid unpredictable delays for dynamic allocation. It also runs on a minimal overhead, so it's perfect for small devices like watches, medical monitors, or embedded controllers. uh, with this much, I would like to conclude my part of the slide and hand over the further presentation to Rajak Singhwal.
Thank you, Rohan, for providing such wonderful insight about the topic. I am Rajak Singhal. I will be continuing this presentation. Today, I am going to talk about some popular RTOS system and where we use them in real life. Uh, First, what is RTOS? It stands for Real-Time Operating System. It helps control devices that need to respond quickly and work without delay. Now let's look at few examples. First one is free RTOS. This is free and open source. It is used in small devices like smart sensors, fitness trackers, and IoT devices like smart lights or smart locks. Next one is VX This is very powerful and fast. It is used in spacecraft and military tools. For example, in the Mars rover, VX runs. Next one is QNX. You will find QNX inside cars, especially in the dashboard screen and system that help the driver. Companies like BMW and Audi use it for their informational systems. Next one is RTEMS. This is one of the most used in scientific projects like space research, medical imaging machines, or even in nuclear labs. It is built for complex tasks. Moving on to the next slide. Now let's see where the RTOS is used in our daily life. First, we talk about automotive cars. RTOS is used in anti-locking braking system AVS, which stop your car safely. It also helps in automatic driving and engine control. Next is consumer electronics. Think about the smart TVs, Bluetooth earphones, smart watches, or Alexa. RTOS is working inside to make them respond fast. Next one is aerospace. In airplanes, RTOS helps in flight control, GPS navigations, and even drones. For example, drones we use for filming or railway use RTOS to fly safely. Next is medical devices. In hospital, RTOS runs in pacemakers, infusion pumps, and testing machines to keep them working safely and on time. So, in simple words, RTOS is like a fast and a smart brain that helps machine work quickly and safely, whether it's a smartwatch or a self-driving car or a satellite in space. That's it from my side. Thank you for listening. Now, I'd like to hand this presentation to my friend, Safal Reddy.
So thank you, my friend Razak, to hand over these slides. Now I would like to take over the slides and continue the remaining parts. So let's talk about some of the challenges and limitations of real-time operating system on this slide. While RTOS is incredibly powerful for time-sensitive applications, it's not without its hurdles. I don't think there are any apps, powerful apps, which may work without any hurdles or without any challenges and limitations. So, as in the slide, we can see the first there is a complexity. Designing an RTOS systems is like solving a tricky puzzle. It requires deep expertise because you need to make sure tasks happen exactly when they were supposed to without any delays. This isn't something just anyone can do. It takes skilled engineers who understand both hardware and software. Next, we have resource constraints. RTOS often runs on devices with limited memory and processing power, like a smartwatch or a car's braking system. This means the code has to be super efficient, almost like fitting a big wardrobe into a tiny closet. Every byte of the memory and every cycle of processing power counts. Then there is a debugging difficulty. Finding and fixing errors in the RTOS can be tough. Sometimes problems only show up under specific timing conditions, and they don't consistently. It's like trying to catch a glitchy ghost that only appears at midnight. Finally, security is a big concern. Since RTOS is used in critical systems like medical devices or cars, they need to be protected against cyber threats. Imagine a hacker trying to mess with a pacemaker. That's why robust security is crucial. But it's not easy to implement because RTOS require precise timing control, complex task scheduling, minimal latency, and also difficult in debugging. So while RTOS is amazing for real-time tasks, these challenges make it a tough nut to crack, requiring careful planning and expertise. So now let's move to the conclusion part. Wrapping up with the key points about real-time operating system or RTOS as shown in the slide. RTOS is all about precise, timely task execution, which is critical for systems under delays aren't an option, like a car braking system or a pacemaker. It uses a scheduler to prioritize tasks, task management to keep everything organized, and interrupt handling to respond instantly to urgent signals, like a sensor detecting an obstacles. This ensures predictable, fast performance for time-critical applications. RTOS is also expanding into exciting areas like self-driving cars, smart devices, and IoT, powering innovations in our connected world. From automotive to medical to aerospace, RTOS is the backbone of systems we rely on every day. In short and in summary, RTOS makes sure critical technology works reliably on time and its role is only growing. And that brings to our final slide. A very big thank you to our expected teacher Manoj Sakya. We have covered a lot of topic today about real-time operating systems, from what they are, their types and their key components, to their applications and challenges. We hope you have gained a clear understanding of why RTOS is so vital in today's technology, powering everything from cars to medical devices to spacecraft. On behalf of our team member, thank you, sir, for your valuable time and your attention. We would love to hear your thoughts and feedbacks. Thank you.